Welcome to this Eastwood Ringing Academy training workshop on call changes. I'm Richard Wolfgang and I will be going through some of the theory surrounding ringing call changes which we don't usually have time to discuss during practice nights. The workshop has essentially got four aims. The first of which is to understand the theory of call changes, what the calls mean and how we implement them. The second is to know what some of the musical rows are called and how they are derived. The third is to understand what we mean by speed and when we use phrases like quicker or slower and how to control our speed. The final aim is then to be able to very precisely move our bell from one place to another in one stroke. As I've always said in the tower, the main issue holding back ringers' progress is poor handling. Good, neat, tidy handling gives better bell control. You need to be able to make the minute adjustments to keep your bell striking in the right place, but as we will see, also to make the big one-place jumps that occur between rows. In all our practices and workshops, I and the rest of the teaching team will be trying to help iron out any handling errors. So we're going to have a quick recap then of some of the ringing terminology and jargon that you should already know. The first thing we're going to look at is the balance point of a bell. The balance point is when the bell is pointing face upwards and the bell is balancing, as the name would suggest, on its gudgeons. It's actually usually just slightly to the stay side of the balance so that we can either allow it to continue gently onto its stay or be pulled just over the balance where it will begin its rotation for a full stroke. You will have already come across standing your bell because that will have been the end command of rounds. Standing your bell, which is sometimes called setting, means parking it in the up position, and this can occur at either hand stroke or back stroke by gently allowing the bell to pass balance point and come to rest with the stay against the slider, or in some cases engaged in a Hastings runner. If we look at the two pictures on the screen, you can see the bell set at hand stroke with the rope going around the bottom of the wheel, so there is less rope wound around the wheel, as opposed to the picture on the right where the bell is set at backstroke and the rope is going all the way around the wheel to the opposite side. You can see the slider in its cage at one side or the other depending on which stroke we are set at. The pull off is the final thing. The bell is pulled to balance as shown, and then the ringer can simply pull it over and it will begin its rotation. Rounds is the final thing, and this is rounds on 6. All the bells are rung sequentially and evenly from the treble down to the tenor. Note the little gap at hand stroke. The other thing that ringers get wrong quite a lot is what we mean by taking up or letting out tail. There are several phrases which ringers use to ask a learner to take up the tail. We can say take up, or take in, or shorten, and some people even say shorten your backstroke. But it all means the same thing. You are going to move up the rope towards the sally, so the rope is in effect slightly shorter. The opposite is true when we ask you to let out a rope, or move down the tail, lengthen your tail, lengthen your backstroke, etc. And you will allow the rope to slip gently through your fingers until the right point has been reached on the tail end. Now that we're moving on from rounds onto call changes, there are some more terms that you need to be familiar with. And it is important to understand them accurately, as they do have very specific meanings and are not necessarily interchangeable. The first thing we need to know is a row. And a row contains all the bells once, in one order, and each bell is in one place in the row, i.e. they could be the first bell to ring, the second bell to ring, the third bell to ring, etc., which puts them in first, second or third place, etc. Rows can often have specific names, and rounds is the name for the row that is 1, 2, 3, 4, 5, 6. When you have two rows and they are different, the change is the transition that occurs between the two rows. Every bell can move a bit like a king in chess, so you can either ring one place earlier than you are already, or one place later, or you can stay in the same place. Going back to the idea of places, the first bell to ring in a row is in first place, and this is said to be leading. The last bell in the row is said to be lying. If there are 6 bells, that will be 6th place. If there are 10 bells, that would be 10th place. But it is always the last bell to ring. The first bell to ring, and leading, occurs at what is known as the front of the row, which if you were to look at it on paper will be the left-hand side. And reading from left to right, as we traditionally do, lying will occur in the last place, which is referred to as the back of the row. When moving between places, a bell changing to a place nearer the back, i.e. last place, we call moving up or moving out. A bell changing to a place nearer the front, i.e. first place or leading, is moving down or in. The person who controls the ringing is the conductor. They are the only person who should be speaking during any piece of ringing. You should do exactly as they ask without questioning it. It is their fault if you are then wrong, not yours. The utterances made by the conductor are called calls, and calls can be anything such as stand or rounds, or telling a pair of bells to swap over, for example 2 to 3, which we will explain in the next few slides. So what do the calls mean in call changes? You've heard things like 2 to 3 and 3 to 4. These are all calls, and it is the conductor's aim to move the bells from one set of a musical named row to another by swapping pairs of adjacent bells. There are various rows which are more musical than others, and they have generally been given special names. We already know what rounds is. It is the bells ringing from the highest bell down to the lowest bell, and it should sound something like this. And numerically it looks like that. It is no different on whatever number of bells. It is simply the odd numbers rising numerically followed by the evens. So if we had 12 bells, we would still get the following change sounding like this. And that is Queen's. Moving on from Queen's, if we then reverse the order of our odd bells, we get the rows which are called Kings. And this is simply the odd bells descending numerically, followed by the even bells ascending numerically. So let's see if we can make this work. Well, that's Kings on 8. Moving on from Kings, we can get Whittingtons. Now Whittingtons on 6 is in fact the same as Kings. Whittingtons was originally designed on 12 bells, and you will find that 5, 3, 1, 2, 4, 6 actually occurs twice. So the front 6 do that, and the back 6 repeat it in the form 11, 9, 7, 8, 10, 12. So let's see if we can get it on 8 where we have lost the bells that we aren't using out of 12, which will be the 5 and the 3 and the 4 and the 6 from the first change, so that we end up with the first 2 and then we get the traditional kings on the back 6. And that should sound as follows. Titums is the next change which lots of ringers like because it sounds titum titum titum. This is formed by taking the first bell and then splitting the row in half and taking the first bell of the second half. So that if we've got our ring of 8 bells, we will get something that sounds like this. Exploding titums is a variant on it, and we're starting with the middle pair of bells and we're working outwards this time. So if I can get my text to work for me, it should sound something like this on 8. Roller coaster is a change which is most commonly found on 10 bells, but there are variants of it that sort of work on 6, 8 and 12. But the version on 10 has a very much 3-way hump and a bong on the end. So that sounds like this. It is very difficult to ring these changes without syncopating them, but all bell ringing should be done in a march style. Seesaw is another musical change where the front bells are rung in reverse rounds order and the back bells are rung in rounds order. And seesaw on 8 will sound like this. And the final one, which isn't used very often because it was thought of as a signal of war, fire or something else of a national emergency, will be the bells ringing backwards. And there are 2 variants of this again, in that you can leave the tenor in its last place because that will still sound before the bell that would traditionally have come before it in rounds coming after it. So the 2 versions would be, this will be the back change on rounds on 8, but with the tenor covering. But you could also ring it just starting with the tenor. So moving on from there, we need to start thinking about how do call changes actually work. As we said earlier, you can only swap adjacent pairs of bells. So this means that we could swap the 1 and the 2 so that it became 2-1, or the 2-3, or the 3-4, or the 4-5, or the 5-6. Any pair can swap as long as they are actually next to each other. How do the calls work themselves? There are several different ways of calling the same pair of bells to switch places. The most common is with bells being called up, as it is known. So we're going to look at the change 2 to 3. This is where the 2 is told to follow the 3. This means that the 2 moves up 1 place, and this, because it's a swap, must make the 3 move down 1 place. So the next row after the call would be, there's the treble, the 3 has moved down to a 2nd place, and the 2 moves up to 3rd place, and the 4, 5 and 6 are all left completely unaffected. The same can be achieved by calling the bells down. In this instance, we're going to call 3 to 1 because we still want to swap the 2 and the 3. So here we take the 3 and we make it follow the 1. Because it's going to move forwards to where the 2 is at the moment, the 2 is pushed out of the way and rings after the 3, causing the same swap as in the previous example. So there's the treble, it has not moved. Here is the 3, which was told to follow it. And here are the other 4 bells. The first way is easier in terms of the 2 bells that are going to move are both called 2 to 3. So we know that the 2 is going to move and the 3 is going to move. However, the bells being called down, there is no mention of the 2, but it still has to move. There are certain advantages to calling the bells this way, and down in Kent, where I learnt to ring, that is the more common way of doing it. So the 3 was following the 2, but has been told to follow the 1. The 2 was following the 1, but it hears the call and knows that the 3 must now follow it. So it must now follow the 3. This is all well and good. The only bell who does not necessarily know now who they are following is the 4. However, the 4 does not change speed, so they can continue ringing at the same speed until they work out that they are now following the 2. It is also possible to swap bells simply by calling their places. As we can see in rounds, the 2 is in seconds place and the 3 is in thirds place. If we call the places to swap, seconds and thirds place swap, then the second and third bells must just swap places, which gives us the same row as in the previous 2 examples, simply called in a different manner. The final way, which I dislike intensely, is to call the entire new row out, like a telephone number. This is not too bad on 6, but when you get to 12 bells, the change has happened before you've even finished shouting out the number, assuming you didn't get lost halfway through it. The other problem is that, certainly in my case, if I'm ringing bell 2 and I hear this change being called out, 1, 3, 2, 4, 5, 6, I hear 2, which is me, I immediately hear 4, and I think, oh, I must follow the 4. However, that will not result in the desired row. So, let's think about ringing individual bells and what happens to them when changes are made. And for the purposes of the rest of the explanations, I'm going to use the up method of calling call changes, because that is the method most commonly employed in this area. So, if we go back to basics, the first thing we must do is make sure we know which bell we are ringing. It is very easy in a strange tower to forget which bell you are on. It is also, if you have, say, 8 bells in your tower and you decide you're going to ring the middle 6, which will be 2, 3, 4, 5, 6, 7, that if you are ringing the 3rd, which is in fact bell number 4 of the tower, you might easily mistake it and ring in the wrong place. Do listen to the conductor and concentrate. It is very easy to miss a call or to mishear it. Or, as I was once ringing for Evensong at Derby Cathedral, where one of the ringers missed the call, the conductor shouted at him, he missed the call again, the conductor shouted loudly, and the ringer removed his headphones from where he was listening to the Archers. This is not the way forward. Pay attention. Call changes are always called at handstroke. And, like all calls in ringing, they take effect a whole pull later, i.e. the next handstroke. This is because, as we will discover later on, everything you do applies to the following stroke, so we need time to set ourselves up to make the move between positions. If your belly is one of those called to move, you must do so very accurately in one move. If you were the 2 in rounds and you are now called to follow the 3, this does not mean at the backstroke that you ring in 2.5's place before then moving to 3. That backstroke must be accurate and must be the change that it was already in before the change was called. So, let's look at bell 2 in this call. As we've already discovered, adjacent pairs of bells are called to switch places or are unaffected. If you're ringing the 2, there are 5 bells which will sound between your hand and backstrokes every time, which we looked at when we did rounds. And in this instance, if you ring bell 2 and you have your bong, then bell 3, 4, 5, 6 and 1 must ring before you can ring your bell number 2 again, and that is 5 bells. Bell 2 is not mentioned by the call 4 to 5, and therefore it is unaffected, and we would expect it to be in the same place in the following row. This means that you will continue ringing at exactly the same speed and rhythm as you were, and you will still have 5 bells sounding between your hand and backstrokes. We do not expect you to count all these bells, but they are an illustrative point that shows that one bell is overtaking or falling behind when there is a change made if they are affected bells. So there is our new row. The 2 is in the same place, but if we look at 4 and 5, they have been swapped, but we are still unaffected. So continuing on ringing the 2, there is now going to be a call of 2 to 3. This means we are an affected bell, and we have been told to follow the 3. We are the first bell mentioned by the call, and therefore we must move up 1 place. The 3 is the second bell mentioned in the call, and that would move down 1 place. In order to move up 1 place, we have to let 1 bell extra ring in front of us. This will require a slow blow, which will be at hand stroke, as already discussed, because the call will have been at the previous hand stroke. So after your backstroke, there will now be 6 bells sounding before the hand stroke where you make the change. Once the change has been made, you will go back to exactly the same rhythm as you were in rounds, but you will be in a different place, and there will be 5 bells again between your hand and backstrokes. So there's the first 2 bells, and if we count across the screen, 3, 4, 5, 6, 1, 3, that is 6 bells. Then there's us, then there's the rest of the row. We can look at that in slightly more detail. So here we are ringing round, and here's the 5 blows after us, 1, 2, 3, 4 and 5, then us, 1, 2, 3, 4 and 5 again, us, and we keep repeating this until eventually we get down to where the change is called here. The change is 2 to 3. So the next row, which is a backstroke, the bells must remain in the same place. Therefore we still have 1, 2, 3, 4, 5, 6. This is where you will be setting up for the next row. So we will give an extra firm backstroke flick. We're going to catch the sally slightly later and lower, and we have the option of bringing this bell to balance, to wait for the 3 to overtake us. There's the 6 bells, with the 6 being the extra bell, the 3 moving forward. We then have the new order in this row, so there are 2 bells at the start of the row, your bell, and then because we are now going to maintain speed, we are back to having 5 bells between us each blow. Now let's see this working in real life and see if you can follow the rows. We continue like this until the call is made.
Two to three.
There's the extra bell that snuck in at hand stroke, and then back to the 5 bells between our strokes. Note the bells are even, there was no interruption in rhythm as the 2 and 3 swapped. Let's look at what happens to bell 3 in that call, because that is the bell that moved down a place. That means that we must ring one quick hand stroke in order to overtake the 2 and move down one place towards the front of the change. This means there will now only be 4 bells sounding between your backstroke and your hand stroke before the hand stroke change. Then you revert again to the 5 bells. So there we can see 4, 5, 6 and then the 1 after R3, then it's the 3. Then the rest of the bells come back in. We can look at that in the same manner. So there's the 5 bells ringing between our bell. That's where the call is made. And again, in the backstroke, you're going to remain in the same place. But we need to get ready for the following hand stroke. So there will be a very gentle backstroke flick. We're going to catch the Sally a little bit earlier and higher. And we are going to give a good firm hand stroke because we don't want the bell to continue hunting down afterwards. There will be a new order from that row where there is only 1 bell before yours. Again, as we saw there was an extra bell in the last example, there are only 4 bells in this example. 1, 2, 3 and 4. Then us. We have moved forwards 1 place. But to maintain it, we now go back to the 5 bell spacing. And we will continue ringing round speed until there is a further call made. Again, let's see how this works with the audio.
Two to three.
And so on. The next thing we need to understand is what speed is, and how to use it to change position. So what is speed? Well, speed is actually not quite what you might think it is. In rounds, you have tried to keep your bell at a constant speed, or so you think. You try and find the point on the Sally and the tail end where your bell will ring in the right place behind the bell in front of you every time without need for further adjustment. But now that we're ringing call changes, we have to move to a different place, and you will hear people say, ring quicker or ring slower. A bell is basically a machine that you are operating. And in the same way as you would understand a bicycle if you ride one, or if you've got a car, you need to understand the basics of how the control works and what effect our input has on its operation. although we do not need to know every minute detail of the mechanics. For the purposes of this presentation, I have very much simplified the physics and the data that I have used for the bell. So strike points are not necessarily in the right positions because I have altered them to emphasise the points I'm trying to make, and bells do not travel necessarily at a constant speed because from the moment you pull it off it accelerates until the bottom and then it will decelerate as it rises on the other side. But for the purposes of what I'm trying to present, I'm going to assume that we go from 0 to full speed to 0 instantly. The most important thing to note is that the mechanical and rotational speed of the bell cannot significantly change. So despite us saying ring quicker or ring slower, that is not what you are doing at all. The bell does not change speed. It is the interval between blows that we are able to alter. And where it is an interval between blows, that is the frequency rather than speed. So what we call speed is frequency. So watch the bell in this video. There's a full rotation. Watch the clapper. You can see where it hits the side of the bell, which is about when you can hear bell 5 ring. But there is space between the two strikes as the bell moves around the top of the circle. Well, let's just slow that down again and we'll watch it again. I apologise for the audio, but I simply played the clip at half speed. But just see how much space there is at the top that we can alter. So let's look in more detail now at the physics of what is going on. We've already established that we can't change the speed of the bell, and we know that the bell will do approximately 1 revolution every row, which is about 360 degrees, but we can vary this. So if you expect, and I've lined it up for ease of doing the maths, that we're going to use half a second per bell, then if you've got 6 bells, a row will take about 3 seconds. So it's 360 degrees in a circle. 360 over 3 means we're going at approximately 120 degrees per second. We should all know from our very basic school physics and maths that speed equals the distance travelled divided by the time taken, which is why speed is measured in distance per time, as in miles per hour. In this instance, though, it's degrees per second. Again, going back to our school maths, if we have a little triangle like that where S is speed, D is distance and T is time, we can readjust this equation to find any of the 3 letters, assuming we know the other 2. So the time taken will be the distance travelled divided by the speed. And since we know that the speed cannot alter, it is fixed, and we wish to alter the time, the variable we must do is to work out the distance that we need to travel to vary the time to what it is. Now, before you panic and start thinking, I can't possibly do that and ring a tower bell at the same time, you don't have to. This is simply so that you understand what is going on rather than being particularly useful to put your bell in the right place. So if we look at our bell, at the moment this bell is up and is set at hand stroke. This is also the normal stop place for it. If we were to pull the rope downwards, like so, the bell will rotate anti-clockwise, i.e. in that direction. So from here, this arrow will start tracking in this general direction, and we're going to start passing everything else as we go. So there's balance point that we'll pass first. That's where the bell would normally come to a stop at backstroke, and that would be an early stop at backstroke. We come down here to, this is the strike point for backstroke, and the bell continues rotating round in this direction until we get down past the bottom dead to here, and then the bell is swinging. But you can see the bell is swinging from normal stop to normal stop. Where we are at normal stop there, in order to ring a hand stroke, the bell is going to travel all the way down here, right round the wheel, until we get to its strike point there, which I've got in yellow in the next slide, and then it will continue on to the point where it stops before it starts going back the other way. Now if I stretch that out and make it one long line rather than a curve, we get the following. So as you can see, there's my bell. We're starting from a point of 0 degrees rotation. We're travelling down through 15, 45, 75, 105 degrees, 135, 165. Halfway between the 265s is of course 180, which is where the bell is at its dead bottom before we start going up the degrees towards the backstroke. And at 75 degrees the bell will strike, allowing us then to pass the 45 and the 15 for it to stop, turn round, and then go back the other way doing the same thing. The little purple box at 0 degrees is the extra bit added in for the hand stroke gap. So normally 15 is where we stop, but at a hand stroke we're going to go up to 0 degrees, giving us an extra 30. This works for all the bells, and they simply start one after the other so that we can see all of them line up to give us rounds. So going back to our little bell model, there we are sitting there at a normal stop up at hand stroke. We haven't quite reached balance because we don't need to. So if we're going to go for regular round speed, we're going to go from 15 degrees there all the way around the circle to 15 degrees on the other side, and therefore we will not use any of this top section of the wheel. If we want the bell to ring early, we need to stop it earlier so that it strikes earlier and we rotate through less of the circle. Now I've used 30 degrees as an early stop, so the 30 degree point is where the little red arrow on my bell here will point at. And it will rotate round to the 30 degrees on this side. Therefore, we are not using the top section at all, which has got longer. Therefore, the distance it's travelled has become shorter. If we want to ring a late blow, we're going to rotate through more of the circle. And it may well be that we go to balance point or even slightly over it if we wish to hold the bell, where we can hold it almost infinitely, or indeed infinitely, if we set it. So that is the bit of the circle not being used in this instance. It's very short, so the length of pull is, the length of the rotation must be longer. So if we look at it laid out linear as we did earlier, So bell 2 has had to wait longer at its hand stroke, i.e. there, but bell 3 has lost its hand stroke gap and therefore can ring earlier. This means that the 2 has gone from second place to third place, and the 3 has gone from third place down to second place. So let's look at a little bit more of the reality of changing speed on a bell. The first thing is that the amount of energy you put in at one stroke has absolutely no effect on that stroke, but it will affect the next stroke. So if you pull your bell with all your might, the bell will not ring any sooner. What you will do is send it all the way around the circle further than you wanted it to. You then hang off the end of it and hope that you can stop it. Chances are it's gone over balance and you're going to be late at the following stroke. And the same is true if you pull it really hard at backstroke and giving it an almighty flick at the end. You will struggle to stop it when you catch in this alley, and you are quite likely to break a stay, and even if you don't break a stay, your next hand stroke will probably be late. Or it may be early if it just bounced off the stay, which is another common problem with this approach. However, the timing of the pull does matter to the current stroke. So the amount of swing between the clapper striking the bell and it coming to a stop to then reverse its direction is where you do have the control, assuming you have not seriously over or under pulled the previous stroke. The further you allow the bell to rise after it has struck before pulling it for the next stroke, the later in the next row the bell will strike. Conversely, the sooner you bring it to a halt and send it on its way in the other direction, the earlier the bell will strike in that row. To be an efficient ringer, and there are ringers who will ring for 3 hours, which is a peel, or even longer if they're going for a long length, we can't afford to knacker ourselves out by over pulling bells and having to stop them. But we must take pride in our striking. Every blow must be in the right place, with equal gaps on either side. You must listen critically to every blow you make, and make any minor adjustments necessary until your bell is exactly right on the beat. However, we should also be lazy. Never should you have to forcibly try and bring a bell to a stop. If you imagine trying to stop a 1-ton bell, it's going to win, not you. So, the answer is to put in absolute minimum effort to make the bell simply swing round to exactly where you want it to stop without you having to stop it, so that you can just immediately pull the next stroke. So going back to the diagram of my bell and the bits that we did and didn't use of its rotational circle, if you want an early hand stroke, so we stop early, but the backstroke was normal, you must pull the previous backstroke with less force, but still give it a full straight pull, a very gentle backstroke flick, and you'll be catching your sally earlier and higher after the previous backstroke, so that the bell rises less and therefore can strike earlier. You will then start the hand stroke pull a blow earlier than the previous row, and this will move you forwards a place. The same is absolutely true at backstroke, that we put in less effort at the previous hand stroke so that the bell doesn't rise as far, and you will take up a little bit of tail end so that your hands will go as far up into the air as they always will. It will not go over the balance and the bell will stop in the right place. You will again start the backstroke pull a blow earlier than the previous row to drop down a place. If we want to hold up and be late to allow another bell to overtake us, we have to let our bell go through more of the circle. Again, as we know, it is the previous stroke that has the effect on the amount of energy that is required. So we need to give the backstroke just a little bit more oomph for it to rise far enough at hand stroke to allow it to take the extra time. So we'll give it a pronounced backstroke flick. We were going to catch the sally later and lower after the previous backstroke, so the bell rises more, and we can hold it on the balance ad inf if we really need to. And we will start our hand stroke pull a blow later than we did in the previous row. The same is also true for backstrokes, but the setup will be the previous hand stroke, where you give it the full force pull with the flick, and we're going to let out some tail so that again the bell goes further round and therefore will take more time before it strikes again. Again, we will start the backstroke pull a blow later than we would have pulled our backstroke in the previous row. So in summary, make sure you do know which bell you're ringing. We've already said that it's very easy to forget which bell you're on. I've done it myself many times, and you look a real idiot when the conductor says 3 to 4 and you think, oh, it's all right, I'm ringing the 5. Oh, no, I'm ringing the 3 because we're ringing the front 6. Ah, I haven't moved. Crash. Make sure you know which bell you are ringing. Do listen to your conductor. Stay awake, pay attention. If they tell you to do something that you think is wrong, it is their responsibility, not yours. What isn't required is an argument with the conductor where you're sort of debating the merits of their call. It is unnecessary. The conductor is the only person who should be speaking. Changes are called at hand stroke. And because we now know that one stroke has to set up for the next, so if the call is made at hand stroke, you need enough time to set up, so you start setting up at the backstroke, and therefore by the next hand stroke you are ready to be in the right place. If your bell is called to move, do it in one move. You don't gradually creep there, sort of, oh well, I was in 2 seconds place, I'm going to be in 3rd place. In the backstroke, I think I'll be in 2.5s, and well, I pulled it a bit hard, so I'm now in 3.5s at hand stroke, and I'll sort of spiral inwards until eventually 7L pulls later we're in about 3rds places. I've heard many times. It is one stroke that should be different. There should be no alteration of rhythm. And following on from that, once the call has been called at hand stroke, you need to make sure that the final backstroke of the row is accurate. It has not changed. If you were in rounds and they called 2 to 3, that backstroke should still be rounds. Make sure, once you've moved, that you know who the bell is that you are following and which bell is following you. If you are called to move up one place, you will do what is called one slow blow, i.e. there will be a longer period of time between your 2 blows. You must allow one extra blow between your backstroke and hand stroke. So give the last backstroke a little extra flick to ensure that you can fit that 6th bell in. If you are called to move down one place, obviously there will be one less bell in front of you. So you will let the bell go through slightly less of its circle, and you do that by being gentle with the last backstroke, catching your sally a little earlier and higher, and you will find that the bell drops into the right place. I hope that has made ringing call changes slightly more clear, and there are additional resources available with worksheets and handouts, and we do have complete sets of notes. Thank you very much.